These are the notes for the combined gas law. As a reminder, we've been talking about gas relationships. The combined gas law takes the variables we've been looking at, volume, pressure, and temperature, and combines all three of those relationships into one. We talked about how pressure and volume, those had an inverse relationship. Volume and temperature had a direct relationship, and same thing with pressure and temperature. And so what we'll see is we'll see all three of those gas laws we talked about previously in this combined gas law. And so the combined gas law combines those relationships between all three variables, pressure, volume, and temperature, into one equation. And this equation kind of works for everything. If we don't have temperatures, we could always just leave temperature out of the denominator on both sides because that wouldn't be changing. If we don't have pressure or pressure isn't changing, we could remove that there and just have that volume over temperature. Or we could have all three variables changing, and we're looking for one other piece of information. Our reminders, here are units so that we can make sure we're matching up everything appropriately. We need to make sure our temperatures are in Kelvin because we're dealing with gases, and standard pressure is 1 atm and standard temperature is 273. So if we see that in a problem, we need to put those numbers in. It's not going to be a number provided with that. All right, and so this is the equation that we're going to use. How we can identify this is if we have 5 known values where we have kind of 2 pressures, 2 temperatures, and 1 volume, we're looking for that 6th volume. So we're gonna have 2 knowns and 1 unknown. And we're gonna have at least, we're gonna have 2 duplicates, and then we're gonna have that one other thing that we're looking for with that. So 2 duplicates being we would have 2 pressures and 2 volumes and only 1 temperature, or some similar combination of that. All right, so let's look at an example. With these, some of it's just staying organized as well. So a gas initially has a volume of 22 liters and a pressure of 0.7 atm. If we change, I'm going to change the color. So now, because now we are changing to something else, the pressure of the gas, so that it has a final volume of 18.99 liters. What is the final pressure of the gas? The temperature of the gas remains constant. So for this one, this is a little bit tricky. We can use this combined gas law, and that temperature is kept constant. So we could plug an answer, a number in for that, or we could just get rid of temperature from that equation. And so this one, we are seeing that this is a Boyle's law problem because I have a volume and I have a pressure, and then I have another volume. I only have 3 givens, and it's asking for that final pressure. And so because I only have 3 given values, this is not going to be a full combined gas law. We're going to be able to get rid of those temperatures from there. And so with this one, volume of 22 liters, that's going to be my volume 1, and this will be my pressure 1. Our volume 2 then is at 18.99, and that means we're looking for our pressure 2. So we can go ahead and plug that in, and we can just leave out the temperatures because temperature is kept constant, meaning we would just have the same value on both sides, so it would cancel. So we're gonna have pressure 1, 0.7 atm, times volume 1, 22 liters, equals our pressure 2, that's what we're looking for, times final volume 18.99 liters. Forgot my liters over here. So we're going to multiply here. 0.7 times 22 is 15.4, and then P2 P2 times 18.99. And then what undoes multiplication? Well, we can divide both sides by 18.99 in order to find our P2. So those cancel. So P2 is going to equal 0.18 0.81, I'm gonna just round to 2 digits. And pressure 2, we had liters on both sides. And I've got ATM for this pressure, meaning this pressure is gonna have that same unit. And that's our standard unit for pressure. So anytime we're solving for pressure, if we did the problem right, that's the unit we should get out. All right, a gas that has a volume of 26 liters, a temperature of 45 degrees Celsius, and an unknown pressure has its volume increased to 34 liters and its temperature decreased to 35 degrees Celsius. The pressure after the change is 2.5 ATM. What was the original pressure of the gas? So we're given 1, 2, 3, 4, 5 things that we know. We're looking for that unknown pressure, and so this is when we'll use that combined gas law. P1 V1 over T1 equals P2 V2 over T2. With these, when you recognize that, I do like to go through and just write out P1 V1 T1 equal, and then P2 V2 T2, so that I can kind of organize my information from my problem, but you might just be able to read the problem and organize that out. So that volume of 26 liters at the start, I'm gonna just use that first sentence as my starting because it talks about it changing later. Pressure or temperature is 45 degrees Celsius, and unknown pressure, unknown means that's what I'm looking for. I'm gonna look for P1, and then the volume is increased, so 34 liters, and its temperature is decreased to 35 degrees Celsius, and the pressure is now 2.5 ATM. So I'm just kind of writing all that down. I can see I've got 5 things that I know and 1 thing that I don't. Before I start plugging things in, I need to check my temperatures and make sure that those are in Kelvin, and they're not. So I need to add 273 to my Celsius in order to get Kelvin temperatures. So 45 plus 273 is going to be 318 K. 35 plus 273 is going to be 308 K. And those are the temperatures I need to use to plug into my equation. All right, so plugging those into my formula, P1 is what I'm looking for, times 26 over T1, 318, make sure you grab your Kelvin number, equals P2, 2.5 times V2, 34, all over 308. With this, you can also do cross multiply here, cross multiply and then divide, or you can calculate out this value and then isolate P1 over there. I prefer to cross multiply, but you can use whatever math methods that you prefer. So I'm going to have P1 times 26 times 308. I'm going to do that 26 times 308 as I'm writing it down. So we're going to P1 times 8008 is going to equal 318 times 2.5 times 34. So 27030. To get P1 by itself, the opposite of multiply is divide. And P1 is going to equal, these cancel. And I got 3.375. I'm going to go 3.38. And again, what is my unit on pressure? My unit on pressure is ATM. So 3.38 ATM is our final answer. Take a second. I have the next one filled out for us. So maybe pause the video on the next one, see if you can get everything assigned with their values, and then come back to solve or to check your answer. All right, I've got everything kind of filled out. I identified what I need. This one had my temperature already in Kelvin, so I didn't have to do any converting and then plugging those things in. Last time I did cross multiplying, where I just did these two together and then I multiplied these together. You are welcome to do that. I'll go through the other way we could do this as well. So our 1.23 V1 over 115 is going to stay, but I'm going to just go ahead and do all this calculation. So 1 times 29 divided by 225. And this is 0.128 repeating. I'm going to just leave that number in my calculator. So if we want to get V1 by itself, we need to start moving things away from it. So farthest away is this division. So opposite of divide is multiply. So I'm going to multiply both sides times 115. And then I get 1.23 V1 equals, and when I did this, I got 14.82 repeating. Now we've got, these are connected by multiplication. Well, the opposite of multiplication is division, so divide both sides by 1.23. And V1 is by itself. V1 equals 12.05. I'm going to just go 12.1. And then volume, my unit is liters. So volume 1 is 12.1 liters. All right, there's practice posted on Schoology. Reach out to your teacher if you have any questions.